Close your eyes for a second and try to remember being 2 years old. Go on, try, nothing, right? Now try to remember being 1. Or the moment you first opened your eyes in this world. The first time you heard your mother's voice. The first time you tasted food. The first time you laughed, all of it gone like it never happened. And here's what makes that terrifying. It did happen, you were there. You lived through every single one of those moments. You cried, you felt, you experienced the world with raw, unfiltered intensity. Babies feel everything, hunger, warmth, fear, joy, all of it at full volume with nothing to filter it out. And yet, by the time you're old enough to sit down and think about it, every trace of those years has vanished. Not faded, not blurry, gone, like someone reached into your mind and erased the first chapter of your life. Most people hear this and shrug. Oh, your brain was just too young. Simple. Case closed, but that's not right. That's not even close to right. Because your baby brain wasn't too weak to hold memories. It was doing something far more violent, far more fascinating, and far more strange. And when you understand what was actually happening inside your skull in those first years of life, you will never think about your own mind the same way again. Welcome to Savant POV, where we take the stories buried inside science, history, and human experience and show you the angle no one ever talks about. Every week, we go deep on the things that seem ordinary on the surface, but turn out to be extraordinary once you look closer. If this is your first time here, you're in the right place. And if you've been here before, you already know. Nothing is ever quite what it seems. Let's start with a name, Sigmund Freud. Love him or hate him, in 1905, he became the first person to formally put a name to the thing we're talking about today. He called it infantile amnesia, the near-universal human experience of having no memory of the first 2 to 3 years of life. Freud, being Freud, had a very specific theory about why it happened. He believed those early memories weren't gone, they were repressed, buried deep in the unconscious, because the experiences of early childhood were too raw, too primal, too connected to things the conscious mind couldn't handle. In other words, he thought your brain was hiding those memories from you on purpose. It was a compelling idea, and it was almost entirely wrong. Because modern neuroscience has given us a completely different answer. And it's far stranger than repression. It's stranger, honestly, than almost anything Freud ever imagined. Part 1. Babies can remember. Before we talk about why the memories disappear, we need to establish something important. They were there in the first place. This isn't obvious. For a long time, people assumed babies were essentially blank slates, that their brains were too undeveloped to form memories at all. But in the 1980s, a psychologist named Carolyn Rovi Collier at Rutgers University ran a deceptively simple experiment that changed that assumption permanently. Here's what she did. She took infants, some as young as 2 months old, and tied a ribbon from their ankle to a mobile hanging above their crib. The babies quickly figured out that kicking their leg made the mobile move. And they loved it. They kicked and laughed and kicked some more. Then she took the mobile away. Days later, she brought the same babies back and hung the same mobile above their cribs. And the moment they were placed underneath it, they started kicking, immediately. Without hesitation, they remembered. 2-month-olds could hold that memory for a couple of days. 6-month-olds remembered for weeks. The older the baby, the longer the memory lasted. These weren't accidents or reflexes. The babies only kicked when they saw the same mobile, not a different one. They had formed a specific associative memory and held on to it. So the brain of a baby is not a memory-free zone, far from it. Infant brains are constantly learning, constantly recording, constantly updating their model of the world. Every face, every sound, every pattern, every sensation, all of it is being processed, encoded, stored. And yet by adulthood, every single one of those memories is gone. Not one survives into conscious adult recall. So the question isn't whether babies can form memories. They can. The question is, what happens to those memories? Where do they go? Part 2. The engine that forgets. To understand what goes wrong, you need to understand how memory is supposed to work. Deep inside your brain, tucked beneath the cortex, shaped like a small curved seahorse, is a structure called the hippocampus. It is, in many ways, the engine of human memory. When you experience something meaningful, a conversation, a loss, a moment of joy, your hippocampus is what takes that experience and converts it from a fleeting impression into something that can be stored, retrieved, and replayed. It does this by working in close coordination with the prefrontal cortex, the part of your brain responsible for complex thinking, planning, and self-awareness. Together, they tag experiences with context. When did this happen? Where was I? How did it make me feel? Who was there? That tagging process is what turns a raw sensory experience into a narrative memory, a story you can consciously revisit. But in infants, this entire system is severely underdeveloped. The connections between the hippocampus and the cortex are still being built. A key region called the dentate gyrus, which acts as a gateway for new memories entering the hippocampus, isn't fully wired until somewhere between ages 2 and 4. The prefrontal cortex, which provides the context that makes memories retrievable, won't reach full maturity until your mid-20s. So what this means is, your infant brain could form short-term memories. It could hold them for days, maybe weeks, but it couldn't transfer them into long-term storage. It couldn't tag them with the context needed to make them retrievable years later. The memories formed, flickered briefly, and then faded like writing in sand at the edge of the ocean. That's the first part of the answer, but here's where things get genuinely strange. Part 3. The brain that ate its own memories. In 2014, two neuroscientists at the Hospital for Sick Children in Toronto, Sheena Josselyn and Paul Franklin, published a paper in the journal Science that turned the field on its head. Their hypothesis, when they first proposed it, sounded almost absurd. They asked, what if the very process that builds your brain is also the process that destroys your memories? Here's what they were getting at. In the first years of life, your hippocampus is producing new neurons, new brain cells, at an extraordinary rate. This process is called neurogenesis, and it's absolutely essential. Those new neurons are what build the circuits you'll rely on for the rest of your life. Every new connection, every new pathway, every new capability your brain develops in childhood, all of it depends on this flood of new cells. But Josselyn and Franklin suspected there was a cost, a serious one. Every time a new neuron integrates into an existing neural circuit, it physically disrupts the connections that were already there. It forces those existing connections to rewire, to accommodate the newcomer. And those existing connections, they were the ones holding your memories. To test this theory, they ran experiments on mice. When they artificially increased the rate of neurogenesis in adult mice, flooding their hippocampus with new neurons, those mice started forgetting things they had previously learned. Mazes they had memorized, patterns they had recognized, gone. And when they went in the opposite direction, slowing down neurogenesis in young infant mice, something remarkable happened. Those infant mice held onto their memories far longer than normal. Memories that would typically fade within days persisted for weeks. The conclusion was stark and counterintuitive. Your baby brain wasn't too weak to hold memories. It was too busy growing. The same neurological explosion that was building your mind was simultaneously demolishing the records of your experience. Your brain was constructing itself and destroying its own history at the same time. Think about what that means. Your earliest experiences, your mother's face, the warmth of being held. The first time you felt afraid, those weren't simply never recorded. They were recorded and then erased, over and over again, as wave after wave of new neurons crashed through the circuits that held them. Your brain built new rooms and tore down the old walls to do it. Part 4. The self that didn't exist yet. But there's another layer to this, and it may be the most philosophically unsettling part of the entire story. Even if the structural problems were solved, even if your hippocampus had been fully developed and neurogenesis had somehow left your memories intact, you would still face a deeper problem. Because to form what scientists call autobiographical memory, you need something that most of us never even think about. You need a self. Autobiographical memory isn't just memory. It's memory where you are the main character. It's the ability to look back at an experience and say, "That happened to me, I was there, that is part of my story." It requires a continuous sense of self, an understanding that you are a person, separate from the world around you, with a past and a present and a future. Infants don't have this. Developmental psychologists Mark Howe and Mary Courage laid out this argument in the late 1990s, and it has since become one of the most accepted explanations for infantile amnesia. Before roughly 18 to 24 months of age, infants do not recognize themselves as distinct individuals. They do not have an internal narrator. They experience the world intensely, vividly, constantly, but they do not experience it as happening to a self. The classic test for this is the mirror test. Put a small dot of rouge on a baby's nose without them noticing, then place them in front of a mirror. Before 18 months, babies look at the reflection with curiosity or confusion. They treat it like another child. They don't reach up to touch the mark on their own face because they don't understand that the reflection is them. After 18 months, everything changes. The baby sees the reflection, pauses, and then reaches for their own nose. That small gesture is enormous. It means I recognize myself. I understand that this image in the mirror is me. I exist as a distinct entity in the world. And here's the crucial connection. That moment of self-recognition closely tracks with the earliest age at which autobiographical memories begin to form. Not because the brain suddenly became more developed, though that's happening too, but because there is now a self to attach the memories to. Now there is a narrator to say, "This happened to me." Before that moment, experiences were happening. They just weren't happening to anyone. Part 5. The language that builds memory. There is one final piece of this puzzle, and it's one that changes depending on where in the world you were born. Language. Developmental psychologist Catherine Nelson spent years studying how children form lasting memories. And her conclusion was radical. Language doesn't just describe our memories. It creates them, it gives them structure, it makes them survivable. Before you could speak, your experiences existed as raw sensory data, sounds, textures, temperatures, emotions, flashes of light and color. They were vivid in the moment, but they had no framework, no skeleton, no way to organize themselves into something retrievable. They were, as Nelson put it, like water without a container. Once children begin to develop language, and especially once adults begin having conversations with them about past events, something shifts. Remember when we went to the park? Remember the dog that came running over? You were so scared and then you laughed. Those conversations do something remarkable. They take a raw experience and build it into a narrative. They give it a beginning, a middle, and an end. They attach it to a self. And suddenly it can be remembered. The evidence for this comes from a striking cultural comparison. Psychologist Chi Wang at Cornell found that the age of your earliest memory actually varies significantly depending on where and how you were raised. In Western cultures, particularly American culture, where parents frequently narrate their children's experiences, ask them questions about their feelings, and encourage them to build personal stories, earliest memories tend to begin around age 3.5. Among the Maori people of New Zealand, whose culture places an extraordinary emphasis on oral history, personal storytelling, and the preservation of individual experience, the average first memory reaches all the way back to age 2.5, a full year earlier. In contrast, in certain East Asian cultures where early childhood narratives tend to focus less on individual experience and more on group context, first memories tend to begin closer to age 4 or even later. Same human brain, same neurological hardware, different first memory. The culture you are born into, the stories people tell you about yourself, the conversations adults have with you about your past, literally shapes how far back into your own life you can reach. The full picture. So let's put it all together. Let's answer the question that started this whole thing. Why can't you remember being a baby? Your hippocampus wasn't developed enough to transfer short-term experiences into long-term storage. The flood of new neurons building your brain simultaneously destroyed the memories those neurons displaced. You had no sense of self, no internal narrator, to anchor experiences to a person called you. And you had no language to give those experiences a structure that could survive into adulthood. It wasn't one failure. It was 4 separate systems, all working against memory at the same time. Every human being who has ever lived went through this. Every person you've ever met, your parents, your grandparents, the oldest person alive, has a black hole where the first years of their life should be. It is the most universal human experience there is, and most of us never think about it for more than 5 seconds. And there's one more thought I want to leave you with, because I think it's the one that really sticks. If your infant brain was literally torn down and rebuilt, neuron by neuron, circuit by circuit, into the person you are today, then the baby in your oldest photograph is not quite you in the way you normally think of you. That baby had no sense of self. No continuous identity, no inner voice. The mind that existed then was disassembled and reconstructed completely into the mind reading these words right now. The answer to why you can't remember isn't that your brain was too simple. It's that your brain was doing the most important thing it would ever do. It was becoming you, and that required destroying the person who came before. If this made you stop and think about your own mind differently, that's exactly what Savant POV is built for. Every single week, we go deep on the stories that science, history, and human experience are hiding right in front of us. The stories that most people walk right past without ever stopping to ask why. So if you haven't subscribed yet, do it right now. Hit that button. Because we drop new videos every week. And every one of them is going to change the way you see something you thought you already understood. Give this video a like if it blew your mind even a little. It genuinely helps more people find this channel. Share it with someone who thinks they understand how their brain works. And drop a comment below. What is your earliest memory? How old were you? I want to know. I'll see you in the next one.